My name is Jessica Politz. I'm an engineer with Sonoma Resource Conservation District. And I included my contact info. If you have any questions following this presentation, please feel free to reach out to me. And then I'm also included a link to our website, the website of the Coho Partnership, which is the larger organization that's co-sponsoring this presentation. Sonoma RCD is a member of the Coho Partnership. And then also it's a slightly longer URL, but that's the main website for the City of Healdsburg's recycled water program, where you can find all of the information on that program. You'll hear a lot more detailed information during tonight's presentation, but those are just a few key links if you're wanting any more info. I wanted to ask everyone to please save your questions till the end. We'll just go through the presentations likely through the first hour, and then we'll have a big Q&A panel and opportunity for anyone to ask any kind of questions specific to your property or just general questions. And you're welcome to ask them over the phone or Zoom or type them into the chat as well, but we'll save the Q&A period to the end. So first I wanted to go over our agenda and introduce our speakers. You already know me, I'm Jessica, I'm an engineer with Sonoma RCD. After me, we'll have Patrick Foos. He is the utility engineering manager for the City of Healdsburg, and he'll be speaking about the recycled water program. After Patrick, we have Sarah Nosman-Pierce, who is a watershed scientist with California Sea Grant's Russian River Salmon Steelhead Monitoring Program. And Sarah will be speaking about coho salmon found in Mill Creek and the impact of flow impairment to coho salmon. Following Sarah, we have Krishna Skorko, who is a conservation scientist with Trout Unlimited's Conservation Hydrology Program. Krishna will be discussing stream flow in Mill Creek and wrapping up the presentation. And as I mentioned before, we'll have a Q&A panel at the end. Also available to answer questions during the Q&A panel is Rob Skates. He's also with the City of Healdsburg. He's the wastewater operations superintendent. And we also have Marianne King, who is the water project director, the California Water Project Director with Trout Unlimited. And she's our water rights expert. I shall toot her horn a little bit and can hopefully answer or provide some direction on any questions that may come up regarding water rights. So first, a little bit about the Coho Partnership. It's officially called the Russian River Coho Water Resources Partnership, and it's comprised of 5 organizations: Sonoma RCD, Goldridge RCD, California Sea Grant, Trout Unlimited, and the Water Institute at the Occidental Arts and Ecology Center. It's an organization that was founded in 2009, dedicated to providing long-term water reliability solutions in the Russian River watershed for both communities and the environment. Our main goal is to improve stream flow and water supply reliability in 5 key tributaries in the Russian River that are known for providing habitat for the endangered coho salmon. Mill Creek is one of those watersheds. Another thing we look into is alternative water sources. And so when we learned about the City of Healdsburg's recycled water program, it really sparked our interest because it's an excellent opportunity for an alternative water source for many different water uses in Mill Creek watershed. It also covers Dry Creek watershed, but our Coho Partnership's primary interest is Mill Creek because it's such a well-known and significant habitat for coho salmon. So that's kind of a little bit of backstory about why we're involved in supporting this program. We approached the City of Healdsburg with a little bit of curiosity and interest when we learned about their program, and we agreed to conduct this kind of collective outreach to see if we could share more information about Mill Creek watershed, about the salmon population, and also about the recycled water program, with the goal of potentially getting 1 or more landowners hooked on to the recycled water program, or at least having more knowledge about it and more thought about how their water use can potentially impact stream flow and coho salmon in the Mill Creek watershed. So that's all I'll say. It's kind of a brief overview of what we're going to talk about. And next up, I'll hand it over to Patrick, the engineer with City of Healdsburg.
All right, thank you very much, Jessica. My name is Patrick Foos. I'm engineering manager for the City of Healdsburg. I work in the water and wastewater utilities. And at some point, Rob Skates can jump in at any time if I make a misstatement or if he needs to add additional information. And we're going to talk about the City of Healdsburg Recycled Water Program. Just to give you a brief outline of what I will talk about, it's start out with a background of why we have a recycled water program to begin with and how that all started. Some of the more recent modifications to that program that are currently under construction. Just to assure everybody, irrigation or agricultural irrigation is key to the success of our program. So it's going to continue. And I have some slides that bolster that. There are some other beneficial reuses that are competing for our attention. I'll mention a couple of those. And then a slide on where do we go from here, from this point. And then if you're wanting to save questions to the end, Jessica, I'll hold off on the questions slide, or did you want to entertain questions at the end of the presentation?
Let's hold them till the very end.
Very good. I won't jump into that. All right. All right, so a little bit of background. The City of Healdsburg has a wastewater treatment facility at 340 Foreman Lane. It's just a little bit east of Feltus School. And we've been occupying that site since the early 1970s. And there's a photograph here from 2002, but the place hasn't changed a whole lot from 1972 until 2006 when the current treatment plant got constructed. The original treatment plant was a pond treatment plant. So sewage from the city would come to the wastewater plant and then flow from one pond to the next, getting progressively cleaner, and then ultimately get chlorinated, dechlorinated, and discharged. We discharged to Basalt Pond, and for the longest time, put the water in, and the pond never filled up. Well, the courts in the 1990s determined that Basalt Pond was indeed a part of the Russian River, so they discovered where that effluent was going. But the result of that court finding was that the city's discharge needed to comply with the Regional Water Quality Control Board's basin plan, which calls for a significant higher level of treatment. So in August of 2008, the city began operation of the newly constructed reclamation facility, and it's a tertiary treatment facility. So we use mechanical screens to take out trash and debris from the wastewater. Then the water flows into a mixture of aerated pond or aerated basins and non-aerated basins, and it uses bacteria in those particular basins, a different kind of bacteria in each one, to remove ammonia and carbon-based pollutants. And then it's the wastewater is followed by filtrations because the bacteria have consumed the pollution. The filters remove leave the bacteria behind, and only clear water is sent off for disinfection. Disinfections by UV light instead of chlorine anymore. And then ultimately we discharge to the basalt pond still when there's not another place for the recycled water to go. The upside is that we have a very high level of treatment, and that's required, interestingly enough, from for the time that we're not discharging or not recycling the water. The high quality water is a requirement for the day in, day out during the winter months. During the recycled period where we're delivering it to vineyard irrigations or to landscape irrigators right now, a lower level of treatment is required by the regulations, but we provide a higher level of treatment because we can. All right, so the city's wastewater operation is under a pretty significant regulatory oversight. So we operate under an NPDES permit, National Pollutant Discharge Elimination System. It's administered through the North Coast Regional Water Quality Control Board. And one of the key compliance aspects that we're having to contend with is complying with the basin plan, which requires that when we discharge to the Russian River, it's tertiary treated. And when we're not, there are times in the year when we can't discharge. And that's from the middle of May to the end of September. And during that time, we need to find something else for it to do because it can't stay here. We struggled a little bit at the onset of the operation of the plant, and eventually the regional board issued a cease and desist order to get us to stop and develop a plan to curtail the discharges to the basalt pond and ultimately the Russian River during those discharge prohibition periods. So the goal was to develop a plan, and ultimately our goal was to make that as cost effective as possible, because our ratepayers are paying. And to give you an idea of the scope, on a normal year, this is hardly a normal year, we can produce approximately 138 million gallons of recycled water during that prohibition period. Right now, we're producing somewhere between 0.6 and 0.7 million gallons per day. So it's, and 138 million gallons for that discharge period is conveniently 1 million gallons a day. All right. So what steps have we taken towards that compliance? So since the onset of the discharge prohibition period and moving towards requirements, we've constructed the wastewater plant. We affectionately refer to it as the WRF, which is the Water Reclamation Facility. It also includes 25 million gallons of storage. We did have to fight with the regional board to get recycled water permitted for agricultural use, and that's been achieved. We've constructed pipelines to deliver reclaimed water on the north side of Dry Creek up to Kinley Road. There's 2 truck filling stations, one at the wastewater plant and one over by Opperman's. If you're familiar with that area, it's just a little bit south of the intersection of Kinley Road and West Side Road. And lastly, we've constructed some reclaimed water pipelines that generally head south about 3 miles to the terminus of that pipe is the Del Rio Vineyard for Gallo. It's right across the, on West Side Road, it's about where the Booker Dairy Farm is, if you're familiar with that. And then we have a pipeline, it's a 12-inch pipeline that's on Foreman Lane that runs out to more or less the intersection of West Side Road and Felter Road on the east side of just underneath the bridge. We've worked with the state to expand our uses. Our initial permit was limited to vineyard irrigation only and landscape irrigation. So there's other agricultural uses that could be used. So we've got a petition in with the state to get that done. But our overall goal is to help, promote the preservation and protection of existing groundwater and surface water sources. And an obvious conclusion that you can have is, well, what will the farmers use if they can't use those sources? And recycled water would definitely fit that bill. We have the truck hauling boundary that's depicted here. The City of Healdsburg is the orange colored chicken shaped region right there, just to give you a place in the map. Our overall truck hauling boundary exceeds 360,000 acres. Okay, so we had kind of a rough start, and then we really buckled down and started pursuing our recycled water program in earnest, engaging the farming community that's adjacent to our wastewater treatment plant and extending pipes to reach more and more over the course of years. And then as the pipes were in place, encouraging the farmers that were in reasonable reach of the recycled water line to tie in and use it. And you can see that we've had some progress over the years. We started out with a 18.6 million gallons not being discharged. And last year we had 102 that was prevented from being discharged to the Russian River. And it ended up being just 3 million gallons short of full compliance with the basin plan. I did put some numbers up to reflect this year's numbers, but it's not going to be a hardship at all to meet full compliance with the discharge prohibition. On one hand, the raw product, the sewage coming from the city is down because of irrigation restrictions and water use restrictions on the residents. And the usage of the recycled water is very high. So we're pretty confident that 2021 is going to be in compliance, but I've got to stay on this. Other years, it's going to rain in the future. We are going to need more involvement with the farming community and recycled water use to make full compliance for our 138 million gallons, which we will get eventually. So some of our program modifications which are in place, the areas that are depicted in the map in pink and in green, those were covered under our environmental impact documents and under our permit from 2025 or 2005 for the pink areas, and the green expanded out to the in 2016. In 2019, we had a subsequent EIR, which extended the service area to the crosshatched areas and the stuff that's in a salmon colored. We've petitioned the state to allow additional irrigation uses to include pasture and hay, orchards, cannabis, and other non-vineyard or landscaping uses, while retaining the irrigation for vineyards, of course. The trucking of recycled water had a sunset on it. So one of the modifications is to make permanent the trucking of recycled water for irrigation purposes, and then to expand the service areas to include areas south of what we were able to serve before, and to include the west side of West Side Road. I had some milestones that we have achieved or we're looking forward to achieve, but the point that I would like to make in these next couple of slides is that agricultural irrigation is key to the success of our program. We need to keep the farms engaged in the use of recycled water, and it's ultimately the right thing to do for the environment, but it's also the right thing to do for the farms. So in doing so, we've increased our on-site storage. We do have a second pond that was lined, and that's become engaged. But we've got some construction projects that are going to engage about 150 acres of pasture on the west side of West Side Road, and that should up our ability to divert water from being discharged to the Russian River to about 180 million gallons, more or less. And that becomes more of a management problem for the folks at the city like Rob to make sure that there's enough water to deliver to all those irrigation uses. And this is assuming that everybody's fully engaged and fully using it, and right now, not everybody is. All right, so agricultural reuse will continue. So one of the goals that we have is not only to achieve compliance with that discharge prohibition, but to reliably do so. And the key way to do that is to make sure that you've got a bit more committed for deliveries than you can produce in that amount of time. And then we would, the management idea is we would have to impound a little bit on the beginning so that we would empty the ponds as the year progresses. Right now we're, well, this year's a kind of an exception. Under ordinary years, we're delivering our recycled water for vineyard irrigation and filling the ponds in the process and hoping that they don't exceed the capacity. But farmer participation is going to be required. And one of the challenges that we have moving forward is once we've achieved full compliance, the city's needs have essentially been met. Now the question is, how do we engage more of the farming community and who pays for that? There's pipelines that are out there in the distribution and in the system that are reachable, but it's a significant capital expenditure for the city. And if their benefit has been exceeded, then you know, how does that all look? And that's one of the questions that I think that I might have in the Q&A session is, you know, how does the farming community want to move forward with it? If there's a water source that they can tap into, it's they would need to come to it rather than it coming to them potentially. One of the competing uses that we would need to be cognizant of is urban reuse. So there's parks and schools and athletic fields and that kind of thing in the city. It would occupy about 46 million gallons of that recycled water use. The hitch in that is that it's frightfully expensive to get the pipeline there. The construction requirements are significantly more stringent when you're building pipelines under roads than if you're building them under vineyard roads. But that's at this time during the drought, it's one of the political hot potatoes that we may be contending with. So where do we go from here? One of the first steps, and thank you, Jessica, for spearheading this, is to reach out to the community and see what the interest is in recycled water. And the survey's been done and the results have been compiled. The next step would be to take a look at the return on investment to see what makes the most sense for the city or what makes the most sense for operations. When do we run out of our ability to deliver? And we always need to keep city council engaged. Once we've identified those uses for recycled water, there's a plan to serve them. Again, city council gets engaged, as well as how does that construction get paid for? And once again, city council gets engaged from everything that we do. And that kind of concludes my presentation. Contact information for Rob Skates and myself are here, and these slides will be made available to the people participating in the this webinar. Thank you, Jessica.
Great. Thank you so much, Patrick. So next up, we have Sarah from California Sea Grant.
Hi, everybody. So I am with Russian River Salmon and Steelhead Monitoring Program at California Sea Grant. And as our name clearly implies, we monitor salmon and steelhead throughout the entire Russian River watershed in order to provide unbiased scientific information to all the stakeholders that are involved in salmon recovery. So really, I think the entire watershed community, and the goal is really to help preserve these species for future generations. So while this seems like we're really shifting gears here, it's obviously all very much connected with everything that Patrick just spoke about in the water cycle and water reuse. So I think I'm going to start by just offering a little quick overview of salmonids in the Russian River watershed, because I'm not sure how familiar each of you are. But we have 3 native salmonids, that's fish in the Salmonidae family. Here, those are coho salmon, which are currently endangered, steelhead trout, which are threatened, and Chinook salmon, which are also threatened. All of these fish are anadromous, which means that they're born in freshwater, migrate out to the ocean where they age to maturity, and then they return to freshwater to spawn. And that makes them an incredibly valuable asset to our inland ecosystems. So, aside from feeding us and being an integral part of our cultural heritage, salmon also provide a really critical ecosystem service, which is they essentially fertilize our inland watersheds. They bring back marine nutrients with them from the ocean. And because they die after they spawn, once they die and their bodies are decomposing or they're consumed by other animals in the watershed, all those nutrients are recirculated through the inland watershed ecosystems. As a matter of fact, it's shown in salmon watersheds that 40 to 80% of the nutrients in the trees comes from the ocean. So just an incredibly important piece of this picture after these Pacific salmon and the Mill Creek watershed, the entire Russian River watershed, and all of our Pacific Northwest watersheds evolving with these species for millions of years prior to us being here. They just have an incredible importance to this watershed. And if you guys, I don't have time to get into all this now, but I'm a total nerd, and I just think this KQED Science Special is really cool. It's called There's Something Fishy About These Trees. And if you're interested, I would check it out. So the Russian River coho salmon population has some special importance in terms of like our geographic location. So pretty much due to habitat loss, salmon numbers really experienced like huge declines throughout the 19th century after Western settlement. Today, across California, they're only estimated to be about 10 to 15% of their 1940s numbers throughout the state. All of the salmon and steelhead populations in the state are either threatened or endangered. And here in the Russian, coho salmon are endangered. I walked you through the status of the others, but basically all these fish are really hurting. We don't know exact numbers, but we know that historically tens of thousands of coho salmon return to the watershed to spawn every year. And this was the largest population in the Central California coast evolutionarily significant unit, which basically just means it's genetically distinct. So it's important in that respect. Historically, prior to recent years, we know for certain that coho salmon occurred in 32 of the Russian River streams, including Mill Creek and its tributaries. And so this is a map that shows those streams that historically we know that coho salmon resided in. They were last documented in Mill Creek in 1995, so would have been gone from the system. And this shows that same map of streams where coho were still present by 2001. So you can see they were only found in 2 streams, Green Valley Creek and Dutchville Creek in southwestern portion, or I guess in the western portion of the county, southern portion of the watershed. And only one of those streams had 3 consecutive year classes. So yeah, it was really bad. So by 2001, basically, it was really clear that coho were on the brink of extirpation from our watershed, and there was no possibility of them recovering on their own. At that time, there were fewer than 10 adults documented returning each year. So state and federal and local organizations came together and started a conservation hatchery program known as the Russian River Coho Salmon Captive Broodstock Program. And the goal was to reestablish self-sustaining runs of our Russian River native coho salmon. And the way this program works in a nutshell is that we collected about half of the remaining juvenile coho that we could find at that time. They were brought to the coho section of the hatchery at Lake Sonoma. So that's specifically a restoration hatchery, not run like the game hatcheries. They were raised to maturity, they were spawned, then their offspring were stocked out into selected streams that historically had coho in them. As young of the year, this started in 2004. And then it has occurred every year since. To date, there have been over 2 million coho salmon released into the Russian River streams, always streams, not the main stem, because they reside in the tributaries. And almost 450,000 of those have been into Mill Creek. or the Mill Creek system, I should say. So our program at California Sea Grant is responsible for monitoring the coho salmon in the stream environment. We also monitor steelhead and Chinook as part of a number of different salmon recovery efforts. It's not really necessary to go into those, but yeah, there's a lot going on there. And so basically our monitoring activities follow the life stages of the fish. So each winter from the onset of the rains, hopefully in October, but if we're lucky these days by January, it seems like, we conduct spawner surveys in over 50 streams in the watershed, and that always includes Mill Creek and its tributary streams. We walk the streams looking for adult spawners, carcasses, and their nests, which are known as reds, salmon and steelhead nests. And then basically, I don't have the numbers here today because, well, I'll get to different numbers in Mill Creek of what we've seen. But during these surveys, each year, we inevitably count dozens of returning fish and or salmon or steelhead reds in Mill Creek and its tributary streams. As a matter of fact, those of you that are streamside landowners may have received access calls from us, requests for access, or granted us permission. So thank you in advance if you have. Historically, that was with somebody named Nick Bauer with our program, so you may know Nick. Now that will be Zach taking over a lot of those calls, or myself, but anyway. So also in the early summer months, we snorkel thousands of pools throughout the watershed again, always Mill Creek and its tributary streams. We basically count all of the young of the year, salmon and steelhead. We count them down to species and life stage. This really helps us to determine the spawning success of those adults that returned and document numbers over time. So that's how we know that after 1995, when coho were last seen in the Mill Creek watershed, at least that was documented officially, there were no more coho observed there until 2005, aside from fish being stocked by the broodstock program. So since that time, what we consider naturally spawned coho young of the year, so their parents may have been part of the broodstock program, but they have been naturally spawned in the stream environment, so they've never been hatchery fish. We observe, you know, dozens to even in the low thousands of those fish in Mill and its tributary streams every summer. Last summer, we estimated about 1,500 coho young of the year based on our snorkel counts, and those occur in Mill, Felta, and Palmer. Also, steelhead occur in every stream in the system. We always count them in a little bit higher numbers, hundreds to the low thousands every year. And last summer, we counted 4,000 steelhead yoi. We also conduct smolt trapping every year on Mill Creek and 2 other streams in the watershed. We do this about between March and June. This year ended a little early because things were so dry. We use these data to look at smolt abundance, numbers of fish moving out to the ocean, their overwinter survival. We also use all of our life cycle monitoring data to really we compare outcomes across streams, and we really kind of analyze critically the trends over time. And we use them really to identify limiting factors to salmon and steelhead recovery. And then another very important activity that we're doing 24/7, 365 days a year is pit tag monitoring. So basically a proportion of all the broodstock program fish that are released are tagged with a tag called a passively integrated transponder. As you can see in the picture, it's about the size of a grain of rice. We also tag wild coho and steelhead during some of our trapping and research activities. And then we operate these channel spanning antennas that you can see here, and that detects the time and unique tag number of every fish that passes over them. And this really gives us absolutely invaluable data about fish movement and behavior at all life stages. We operate 14 year-round antennas in 8 different streams in the watershed. And as you can see here, the Mill Creek watershed is circled in red. 4 of those antenna arrays are concentrated in Mill Creek. We really, we've been monitoring Mill since the program began, since before the program began, really by proxy of different partners, but it's really a long-term monitoring, high priority focus stream for these salmon recovery efforts. And also, I should mention that these paired antennas allow us to generate abundance estimates of the fish. We pair them side by side so we can determine the detection efficiency of the antennas and apply the correct equation to actually estimate how many fish return. And that is how we know that the number of just hatchery adult coho salmon at this point, but we know the number of those fish that return to the watershed every year. And so as you can see, since the onset of the program in 2004 was the first release, that we've generally had, pretty decent success with increasing numbers over time, which is an encouraging sign that this strategy is working, that at least these fish have been halted from local extinction. 3 years ago, we actually had a recent record high. We estimated 763 fish returning, but then again, it's so vulnerable. These populations are just so vulnerable to natural cycles and so many impacts along the way. That number was just 214 fish this year, 3 years later, from that same kind of parent cohort of fish. But, between the winter drought and really poor ocean conditions, we weren't too surprised to see the low numbers. And we can also, using our antenna arrays in Mill, look at estimates of returns specifically to the Mill Creek watershed. And as you can see, relative to the numbers of the basin-wide returns, Mill Creek really is an important piece of the system. We've had upwards of 150 fish return in the greatest year since we've been doing this pit tag monitoring in the watershed. Of course, last year, this past winter, very low again, and that correlates to the overall basin returns. So we're also engaged in a number of different specialized studies that help us to kind of get a better understanding of species needs at different life stages. And this has really helped us to kind of whittle down to the limiting factor of, surprise, surprise, stream flow impairment. It's something that we've always known, but we were able through some studies to provide empirical evidence that insufficient summer stream flow is by far the most serious bottleneck to salmon and steelhead recovery in the entire Russian River watershed, and that definitely includes the Mill Creek system. So you can see this is a photo of 2 pools in Mill Creek in 2015 in July, and then these are those same pools just 2 months later. Both of these pools had 100 or so coho salmon young of the year in them at the time that they dried very quickly. And as any of you who have been paying attention to our streams have probably seen, this is a really widespread problem throughout Lower Mill Creek and throughout the Russian River watershed, many other streams as well, that it's been observed for a long time. I've been working in this field in the watershed for 25 years, and I know these problems predate me by quite a bit. So one of the things we did was we began conducting these wet-dry mapping surveys as a way of kind of approximating the impact of stream drying on rearing salmonids. And so I'm going to walk you through how we did that on Mill Creek and what we learned. So basically this map here, it shows, it's a map of the counts and distribution of young of the year salmon and steelhead in Mill Creek. Every circle indicates a pool that was snorkeled. The size of the circle correlates to the number of fish. I apologize for the small legend there, but basically the larger circles indicate a greater number of fish. This happened in July, and we're using 2015 as an example here because 2015 was the driest year in streams at the peak of the last drought. And then we came back in September and we did a wet dry mapping survey where basically we just walked the stream and we documented everywhere the channel was either dry, which is shown as a line here in red, intermittent, which basically was remaining pools separated by dry riffle, shown here in yellow, or still wet at the end of the dry season in September. And that wet line is shown in blue. And then we take both of those data sets and we overlay them. So what you're seeing here is the snorkel data overlaid over the stream channel conditions data. And so we can see where rearing fish were in locations that either dried completely, became intermittent early in the season, or stayed wet through the dry season. So in 2015, I'll just put a little bar graph here for a summary, but basically we counted over 2,500 salmon and steelhead in Mill Creek, and we were able to determine only 11% of those fish were in habitat that remained wet through the dry season. Obviously, that's a huge impact on those fish that really threatens their survival of this whole Mill Creek population. You know, of those fish, only a small proportion are likely to survive, even given, you know, wet summer conditions. They have a lot of other obstacles to face. As you know, and as I mentioned, the summer drying is really not limited to Mill Creek. You can see here, this is a series of streams that we surveyed in 2015. And out of all the 30 streams that we surveyed that year, on average, only about 40% of the total length of all of them remained wet through the summer. And you can see the Mill Creek system is circled there. It's definitely, you know, among some of the drier conditions that we saw. I also want to emphasize this current drought that we're experiencing is more severe than those 2015 conditions. I think you all know that, who've been following the news. There are sort of temporarily wetter conditions this year in Mill Creek as a result of the fire, destroying a lot of the vegetation. And Krisha's going to focus on kind of flow outcomes, but, you know, just, yeah, we're currently in drier conditions, so our fish are hurting out there. And also, I wanted to point out, one of the main flow related concerns is Mill Creek is the early timing of the drying and stream disconnection. This is a graph that shows the average coho smolt run timing when fish are leaving Mill Creek to go out to the ocean so they can complete their life cycle. And it shows disconnection there in that period of the graph that is in pink. That is when the stream was disconnected from Dry Creek. So it happened earlier than we've ever observed since we started our monitoring this year. It totally cut off access to Dry Creek on April 15th for the rest of the season. So I know this is a lot. You know, this is really our $1 million question for those of us working on recovery. And I think it should be for any of us that have a vested interest in our ecosystems in which we live, is just, you know, how can we help ensure that these keystone species don't vanish? And they really are close to that. We're at a time of hope, but it's being sustained by us. So for long-term success, we don't know all the answers, but we know for certain that it's going to have to include returning or increasing stream flow to Mill Creek and other salmon streams in the watershed. So I guess we're here to talk about some ways to do that tonight. And because I didn't want to end on a total, you know, gloom and doom note, I wanted to tell you guys that one of the things that we saw in Mill Creek this year that was kind of interesting is we saw a greater number of wild coho salmon smolts in the system than we've ever seen since we began monitoring, which was really interesting. And what it shows us is that these fish are surprisingly resilient. They made it through the drought of 2020. There were very dry conditions in Mill Creek that year, and they also made it through the Wallbridge fire and the following winter. So, you know, just kind of as a symbol of hope, there is, you know, some resilience in these species. So anyways, thank you very much for taking the time to learn more about this important issue today. We really appreciate it.
Thank you so much, Sarah. That was an incredible presentation, and I appreciate hearing kind of all aspects of fish and specifically the coho salmon in our watershed and in our local watershed. I was thinking maybe we should have started the presentations with doom and gloom and ended with Patrick's about here's how you solve the problem, but we did the agenda backwards, so we'll just go with it. Yeah, so next up we have Krisha. She'll be speaking about stream flow specifically in Mill Creek.
Thanks, Jessica. So again, my name is Krisha Skorko, and I work with Trout Unlimited as a conservation scientist. And I'm going to discuss the stream flow data that we collect in the Mill Creek watershed. And I'll be discussing surface water and groundwater conditions. So I'll begin by giving an introduction to and a background of Trout Unlimited's work in Mill Creek. I'll discuss gauging in the upper watershed, and then I'll give a summary of the 2018 to 2020 surface and groundwater study conducted in the lower watershed by TU and Sonoma RCD. So just to give you some background on TU's work in Mill Creek, TU, formerly CMAR, has been monitoring in the upper Mill Creek watershed since 2010, and we're currently operating 7 streamflow gauges in the watershed. And the data from these hydrologic studies have been used to inform water storage projects, which increase water security and benefit coho salmon and steelhead trout. Other uses of the data we've collected in the area have been groundwater modeling and also fish monitoring by California Sea Grant, including over to the site of a former barrier to fish passage. This is a map of the Mill Creek watershed. You can see the watershed outline here. And this shows our gauging network that we have in the watershed. We currently have 7 surface water gauges, and the upper watershed gauges are the dots that are orange. We have 2 surface water gauges in the downstream portion of the watershed, and also several groundwater wells that we were monitoring as part of our surface groundwater study. This is an example of the sort of data that we collect at our gauging stations. So this is from a gauge in the upper Mill Creek watershed. And what this is showing is for between the years 2010 and 2020, we collect stream flow recorded in 15-minute increments in the dry season, so from May through October. So this is showing 10 years of data, and this is useful in that it allows us to compare stream flow between years, including the many recent drought years that we've experienced since 2010. And the data also show the impact of direct diversions from the creek, and we use that data in development of water conservation and water storage projects. This is a similar plot. It's a little less busy. I'm just showing 4 years of data. I'm showing year 2019, which was a wet year in terms of stream flow, 2018, which was an average year, and 2014, which was a drought year. And the black line that isn't continuous right now because we're still in the process of collecting data is what we've seen so far in water year 2021. So it's another really dry year out there, as most of you know, and these data just emphasize the need for water conservation and stream flow improvement projects. We also compare the stream flow data to the precipitation data recorded in the area. So this plot shows total annual precipitation from 2010 to 2021 at the recorded at the Healdsburg station, NCDC station 3875. So each of the blue lines represents the total annual precipitation recorded at this station. The red dashed line across the top shows the long-term average at this station. And the dotted black line below that shows the average just taken over the study period, the 12-year average, so that we can see the long-term average is about 40 inches of precipitation. Just over the period we've been monitoring, the average is about 10 inches less. And within these 12 years, we see many drought periods starting in 2012 through 2015. We can also see 2018 was a below average year, and then 2020 and 2021 are very dry also. 2021, unfortunately, is the driest year in this record. I'm going to give a brief summary of the Lower Mill Creek gauging and groundwater study that TU and Sonoma RCD partnered on. So from 2018 to 2020, we conducted a study aiming to understand the surface and groundwater interactions in the lower portion of Mill Creek. Lower Mill Creek flows through a fluvial alluvial fan, which is defined as a fluvial depositional feature just upstream of the confluence with Dry Creek. And it's gently sloped here and it's comprised of very porous material. And doing flow augmentation work in this type of setting can be a challenge because it's so porous. There's concern about smolt outmigration in May due to low flow in this section. So we were wondering if there's anything that resource managers can do to increase flow and connectivity. So again, this is the same map of the Mill Creek watershed. So this study is just focused on the, primarily focused on the downstream portion of the watershed here. Our methods for this study, we installed 2 surface water gauges and 1 groundwater continuous well gauge in the spring of 2018 and maintained them throughout 2020. We took manual monthly groundwater measurements at 8 wells. TU and Sonoma RCD partnered in that. We collected monthly streamflow measurements in the dry season, so June through November of 2018 and 2020. And then a total station survey was conducted to tie together the surface water level to the groundwater level. So what this plot is showing is the continuous groundwater level data. So in one of our wells that we monitored, we placed a sensor that recorded groundwater level every 15 minutes throughout the study period. So what this is showing is the March through November groundwater level for the 3 different years. And I've also put the rainfall plot back in the upper right corner just to remind you that 2018 was a below average year for rainfall. 2019 was more approaching the long-term average, but still below average. And 2020 was the driest year of the study. So we can see that the 2019, which is the wettest year, we saw the highest groundwater levels. They dropped slightly in the fall, but not as much as compared to water year 2018 and then water year 2020, when we see groundwater elevations dropping by about 12 feet over the course of the dry season. This next plot is showing our surface water gauge data. So we have 2 surface water gauges, which we call LMO1 and LMO2. LMO1 is slightly upstream of LMO3. And I'm sorry, LMO2 and LMO3. So again, we can see that 2019 being the wettest year in our 3-year study, we saw surface flows that started out at about 10 CFS. We saw a rise due to some spring storms, then a pretty steep descent towards drying, which took place in mid-September. Stream flows were quite a bit higher than they were in both 2018 and 2020, 2020 being the driest year. And in these years, the channel here dried out at about in early summer in June and July. This plot shows a similar data set from LMO3 gauge, which is slightly downstream. And we can see that, again, we start out in 2018, which is also a dry year, at about 6 CFS, and then the channel dries out in mid-July. In 2020, the channel also dried out about then. But in 2019, which is the wettest year of our study, we saw flows persisting in this reach into early October. This is a comparison of that continuous groundwater level data that I showed earlier with stream flow level, stream stage level. So what this is showing is the continuous blue line is the LMO1 well data from its installation in March of 2018 to November of 2020. So we can see that when we first installed it, compared with we compare it to stream flow level, we see that groundwater and surface water start out close to each other, and then we have a recession in the spring. These vertical dashed lines represent when the channel dries out in each year. So we can see that the channel dries out in about mid-July of 2018. And following that, we see a steep drop in groundwater level, and it persists that way through the fall. We see water levels rising with the onset of winter storms, and both groundwater and surface water rise and fall in the winter of 2019. We did have numerous storms in that year. We see another spring recession, and in this year that wasn't as dry, we don't see the groundwater dropping as steeply once the surface water dries out. And the last year of peaks brings us into the winter of 2020, and we see that we don't have nearly as many storms this year. We see again a recession in the spring and summer when the channel dries out which is the earliest drying of the study period, we see that the groundwater drops to its lowest level of the study period following that. So that data was from the more upstream portions of the lower Mill Creek Reach. Moving slightly downstream, this is showing the same surface water level data, that orange line, and then the point data are two nearby groundwater wells. So we can see in this reach that the surface water is perched about 3 to 5 feet above the groundwater during the winter and spring, and it drops pretty steeply into the driest points of the season during the fall. Moving even further downstream, this is our furthest downstream surface water gauge compared with a well that's further out on the floodplain. And we can see that this far down towards the confluence with Dry Creek, the groundwater levels are perched about 15 feet above, or sorry, the surface water levels are perched about 15 feet above the groundwater levels. So it's always disconnected in this reach. I think what's interesting, despite this disconnection, and what that green arrow is pointing out, is that the pools were observed to hold water throughout the fall of 2019, which was one of the wetter years of the study, but certainly not a very wet year by any means. So that gives me some hope that in wetter years and kind of marginal years, the channel can still hold pools and flows can persist further out into the fall. So here's some takeaways from these studies. 12 years of gauging in the watershed have been used to characterize Mill Creek stream flow, including very low flows that we observed during the drought years. And the data has been used in implementation of needed stream flow improvement projects. The 2018 to 2020 study in the lower watershed showed low flows, early drying in the driest years, and limited connection between ground and surface water. The groundwater levels in the very lowest reaches are about 15 feet below the channel bottom, starting in late spring, and yet these perch flows can persist in the fall and wetter years. And finally, both the upper and lower shed could really benefit from additional water resources. And with that, I will give it back over to Jessica to moderate questions.
Okay, thank you, Krisha, and thank you to all of our presenters tonight, and thanks to our audience for staying with us and listening. I think we've presented you with a ton of information about the Recycled Water Program, the efforts of the co-partnership, and our various fish and water monitoring efforts over the last decade plus. So now I'd like to welcome any questions about anything we presented on.